more space than I thought. I guess I just was frustrated with this. Cancel. All right. I'm sorry. All right. All right, so what we need to do here, so we have our function that we have f of x plus h minus the f of x. So again, we're using that formula from up above. Again, we probably need a little bit more space, so I might end up going like just across with this and doing this one in a different spot. I don't know. So I have to put this in for the x values. Now when I go to put that in, I get negative 2 plus h. I have to square that. Plus, because I'm putting it into this formula, 4 times negative 2 plus h. Because I have to put it in there as well, and then plus 4. This is all over h. Because it was, because of the original formula, sorry. Why is it not letting me go back? So we have to do f of x plus h and then minus f of x, and the f of x is 4, or negative 4, right? So we have to include that, so the plus 4 comes from there. All right, so then what we have here, I'm just going to keep going across here. I need to FOIL this. So hopefully you guys are getting a little bit better at FOIL because we've done it so much, but I have to do negative 2 plus h times negative 2 plus h. It's going to be 4 minus 2h minus 2h plus h squared. This is minus 8 plus 4h, and then plus 4. So I'm going all the way across the top here. Now you're going to notice a bunch of things get to cancel at this point. So the 2h's will cancel with this 4. Negative 2, positive 4. The 4 and 4 is going to cancel with the negative 8. And we're going to be, bless you, left with h squared over h, which just equals h. Now, if you remember the original problem, it said we're finding the limit as h approaches 0 of h, because this is what this has become. So as it approaches 0, it's going to also approach 0. So this is just going to equal 0 in this case. So the derivative of that equation at negative 2, 4 is just going to equal 0 after all that.
Wait, and why is that?
Because we're talking about the limit as h approaches 0. Like, as this gets close to 0, that's going to end up equaling, it'll approach 0 as well. And what I did was, I wanted to graph this to show you guys real quick. Again, kind of going back to the graph. So negative 2, negative 4 on my graph, so I just graphed this. That's that point. So the tangent line at that point, the slope would just be 0. So that makes sense that that would be 0 in that place. Okay. All right, let's actually just go to example 2. Example 3 is kind of a silly one because when we're talking about the slope of the line at a particular point, the slope of the line should be just negative 3, and that's what you'd end up finding it to be, so I think we'll just go to example 2. Now this time, again, they're using this new notation. So we have f of x and we have our function. Our definition of a derivative to find f prime, so that derivative at the point 3. Now this time we have to find our y value, which would probably have been a good idea before since my y value was wrong. We have to actually find out what f of x is. So I'll write this formula again so you kind of can see what I'm all doing here. So again, this is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now you'll see a lot of the formulas looking like this 100 minus 16t squared. If any of you guys are in physics, that's a really common equation in physics because this is kind of a parabola that, like if you throw something in the air, that has that shape because 16 is the force of gravity. It's talking about the speed of like gravity on a wall, like how it forces it down to the ground. So the 16 has like a reason, and that's why they use it a lot. So our x is 3, but we have to figure out what f of x is. So we're going to put that in. So we're figuring out our f of x. So 3 to the second times 16, and then 100 minus that. Negative 44, because the other part is negative 144, right? So this is f of x. So we're going to put all our information in here. So I'm going to do f of, and x and t are essentially the same thing, so don't let that throw you off too much. But our x value is 3. And minus a negative 44 over here over h. So now 3 plus h is what's going in to this equation for t. So again, I have to FOIL here, and then once I FOIL, I'm going to have to multiply it by a negative 16. And I kind of FOILed as I went here, and again, if you're hopefully getting better at FOILing a square, that it's, you know, it doesn't take as long to do anymore. These are 6 together. Yes, thank you. I forgot to distribute there. It's negative 16 though, right? All right, you're gonna notice again, all our numbers are gonna cancel, like, right, all our constants. So these are all over h. So I can divide that h out of each of those. So I'm left with, again, I'm going to write that limit back in here. So this is going to be a negative 96 minus 16h. Again, because we divided each of those by h. Now as this approaches 0, what's going to happen to this negative 16? As h goes to 0, this is going to go to 0 as well. So this is going to kind of go away. And so it's going to end up approaching negative 96. Now what that is, it's the speed at that particular point in this situation. So if this is like I'm throwing a ball in the air, and we'll talk about one like that in a second, at time is 3 seconds, the speed is -96. What that probably means is it's falling into the ground at that point. So like you hit a baseball in the air and it's coming back down, or headed back down, the slope is a -96. Okay. So why don't you guys try this one? Very similar, kind of just give you guys some practice. Now this one has 2 places to put, and this should be all T, sorry. T and H are interchangeable there. There's 2 places to put it in though, so careful there. If you're stuck on where to get started, I'll start up here a little bit, but I won't go too fast. Did you guys get this to work out? How are we doing? So I'm going to put this in for both of those. And again, if like foiling off to the side is helpful, you might want to do that. So I have to do this 150 times 2.7 plus h, and then minus 16, and then 2.7 plus h squared. And then I can't forget about subtracting the f of x. So at the FOIL before I multiply by 16, now when I FOIL 2.7, I get 7.29, and then plus I'm going to just add those right away. So 2.7 and 2.7 is 5.4. H, sorry. And then plus h squared minus is 228.36. And this again is all over h. I'll put that back in there in a second. So 16 times 7.29. Times 5.4. Do all the decimals cancel?
Yes.
That's good. Just gonna trust you. And then I put these other ones together. So negative 150 and 86.4 is a negative 236.4 minus 16h squared. Oh, that should have h on it. H squared all over h. So those h's cancel.
Wait. The y is 150 then
Oh, it should be positive. Sorry, thank you.
Okay.
Good catch. I was like, what did I
Is
add?
that right?
You did the same thing round two. Oh, no. At least we're not. I'm rubbing off on you, Tara. You're not supposed to make the same mistakes as me. You're supposed to catch my mistakes. All right, so 150 minus 86.4. Is that better? 63.6?
Yes.
Okay. Now again, those h's are going to cancel out. So I'm going to be left with 63.6, and then minus 16h, but again it's going to approach, h approaches 0. So our derivative at that point is 63.6. So at 2.7 in time, that's going to be like our instantaneous velocity, so our speed at that point. So do I need to show more of that? So if you're wondering what happened here, this was 63.6 minus 16h. And remember, this is the limit as h approaches 0. So as this gets closer and closer to 0, that's going to cancel. And so we're going to be left with just the 63.6.
We could stop it.
Good stuff. You put it in.
Wait, I don't understand how you cancel. Like in the bottom left
Cancel.
equation.
The bottom left.
Like, why do those cancel?
105 minus this all 405. 405, this, and those two negative, these two negative become 405.
Then become negative 405.
And they just end up canceling. All right, we want to stop? We can stop.